What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 37 in the 7th grade math questions that North Carolina released this past school year. The question tells us that Jamal, Gary, Charlie, and Brian are going to stand in a line, one behind the other, and we're just supposed to figure out in how many different ways they can stand in line. Now, the big idea of this question, what you'll need to know to do well on questions like it, is the idea of a permutation or a factorial. And I'll use this question as a way to just briefly introduce what that is. So permutations and factorials come from the idea of the fundamental counting principle, that if we have a few different parts of something that we're putting together or making, whether that's a sandwich or an outfit or anything like that, the total number of ways that we can do that entire thing comes from multiplying each of the number of choices we have from the individual parts or the individual components of that thing. There's other questions that I've done in the 7th grade math that deal with this, so you can go ahead and look for those in the playlist that this video will be filed under. But for right now, I'm just going to say that how many different ways can they stand in the line is going to make use of this fundamental counting principle, and specifically, let's think about who's going first. How many different ways are there, or how many different kids are there who can go first? Let's say Jamal goes first. Gary could go first as well, Charlie could go first as well, and Brian could go first as well. So there are 4 kids who could take up the first spot in line. So let's say that Jamal has gone first, so he can't get in line anymore, and now somebody has to go right behind him. This could be Gary, Charlie, or Brian, so there are 1, 2, 3 choices for someone to be second in line. And now if we think about who could be third in line, let's say Gary was second, and now Charlie and Brian could get in line next. So there's 2 kids who could get in line third. Let's say that that kid is Charlie, and finally that just leaves 1 kid to be last in line. So the number of different orders in which all these kids can stand in line is the number of kids who can come first, times the number of kids who can come second, times the number of kids who can come third, times the number of kids who can come fourth, and that's actually going to be 24. SpongeBob SquarePants has made this one of my favorite numbers, but it's also the answer to a different math problem, which is, you might have seen a problem written like this, 4 factorial. Now, this is not a 4 that's really excited about math. Hardly anyone gets excited about math anymore. This means that if I see 4 factorial, then I'm going to multiply 4 times 3 times 2 times 1. If I saw 6 factorial, I would multiply 6 times 5 times 4 times 3 times 2 times 1. If I saw 100 factorial, I would multiply 100 times 99 times 98, and so on, until I got down to 1. That's the idea of a factorial. We just multiply that number by every natural number, every counting number below it. And either way, this is going to give us 24. This also comes to the idea of a permutation, and I'll very quickly talk about what that word means. Now, I like to think, when I'm trying to think of a good memory trick for this, I like to think of perm like all those 80s movies where everybody's hair was super, like, wild and crazy, but somehow it all stayed in the same place because everybody got perms. The idea of a perm is that it keeps your hair where it is, and in the same way, a permutation is when you pick an order and you stick with it. So order matters for Jamal, Gary, Charlie, and Brian in this problem, and when we do a permutation, we say that there's 4 times 3 times 2 times 1 orders they can go in, which gives us 24. And after all that, I'll finally go ahead and circle that this is choice A.